All right, so today we're going to be tackling a pretty interesting question. It almost sounds like a sci-fi movie title.
Mm.
You know, AI versus quantum computers. Could AI actually render quantum computers obsolete? And we're really looking at this in the realm of scientific applications. And yeah, the research we've got here suggests some pretty wild possibilities.
Yeah, I think it's really fascinating this comparison that's emerging between quantum computers and AI, and just in general the progress that each of them are making in their respective fields.
Absolutely. And the articles we've been reading really dive into this comparison. You've got quantum computers, which have this amazing potential, you know, revolutionizing medicine, materials, science, finance, all these huge fields. But at the same time, AI is making these really incredible strides, especially when it comes to simulating the very systems that quantum computers are supposed to be really good at.
It's kind of like watching a race where both runners have the potential to win, but they're on completely different tracks. Quantum
Yeah.
computers, they leverage the bizarre rules of quantum mechanics to perform these calculations that just wouldn't even be possible on a classical computer.
Right.
Things like Shor's algorithm that could break the encryption that we rely on for online security, or quantum simulations that could lead to, discovering completely new materials and things that we couldn't even imagine before.
Right. So it sounds like quantum computers are these heavy hitters that are swinging for the fences with these world-altering applications. But like any powerful technology, there's got to be some drawbacks, right?
Right. Absolutely. And one of the biggest ones is that they are extremely sensitive. They're kind of like these delicate snowflakes that need to be kept at these ultra low temperatures, and they have to be shielded from any kind of disturbance. So you can imagine how difficult it is to build and maintain these systems. It's extremely complex and very expensive. And then you've got this other problem of trying to integrate quantum computers with the massive amounts of data that we need to process. It's not just a simple plug and play situation.
Right. So it's kind of like having a super powerful engine, but you're trying to stick it in a car that hasn't been invented yet.
Yeah, that's a great analogy. And what's even more interesting is there was a study recently that looked at how these limitations actually diminish the theoretical speed advantages of quantum computers.
Hmm.
So when you take into account the realities of current hardware, the gap between quantum and classical computing, it shrinks significantly, at least for certain types of problems.
Okay, so quantum computers have this incredible potential, but they're facing some serious real-world challenges. And this is where AI comes into play, right? I mean, I keep hearing about AI doing these amazing things, but how is it challenging quantum computers, especially when it comes to scientific simulations?
This is where things get really interesting because AI, and specifically machine learning, is becoming surprisingly good at simulating these complex systems.
Hmm.
So think about trying to simulate the behavior of molecules in a new drug, or modeling the properties of a material at the atomic level. These were tasks that people thought quantum computers were uniquely suited for, but now AI is starting to make some real inroads.
So it's kind of like AI is coming out of left field and saying, hey, I can do that too, and I can do it right now.
Exactly. And one area where AI is showing particular promise is in simulating what are called weakly correlated systems.
Okay, like weakly correlated systems. I'm going to need a little bit of help on that one.
Sure. So imagine you're trying to simulate the behavior of a gas where the molecules are kind of spread out and they're not really interacting with each other that much. That would be considered a weakly correlated system.
Okay.
So the interactions between the particles are really minimal, which makes them a little bit easier to model using traditional computing techniques. And AI is really excelling in this area, using methods like density functional theory, or DFT, to simulate these systems with surprising accuracy and efficiency.
Gotcha. So AI is taking these existing methods and then like supercharging them with machine learning.
Exactly. AI algorithms can be trained on massive data sets of calculations, and they essentially learn to predict the properties of these weakly correlated systems with really impressive accuracy. And what's even better is that these AI models are much cheaper to run than traditional DFT calculations.
Hmm.
So that makes them a really attractive alternative to quantum computing, at least for certain types of problems.
All right, so we're talking about AI that's faster, cheaper, and just as accurate. Is this the beginning of the end for quantum computers in these areas? Could AI actually make some obsolete before they even have a chance to really take off?
Well, that's the big question, isn't it? And for these weakly correlated systems, AI is showing some really impressive capabilities. But it's important to remember that this is just one piece of the puzzle.
Right, so let's unpack that puzzle a little bit. You mentioned density functional theory, or DFT, as one of the tools that AI is using to tackle these simulations. Can you break that down a bit for me? What exactly is DFT and how is AI making it even more powerful?
The DFT is kind of like a virtual toolkit for understanding how atoms and molecules behave. Imagine you're a chemist and you're trying to design a new drug. You need to understand how the different atoms in that drug molecule are going to interact with each other and with the target proteins in the body, and DFT allows you to simulate those interactions and predict how the drug will behave at the atomic level.
So it's like having a super powerful microscope that lets you see and manipulate the tiniest building blocks of matter.
Exactly, and it's not just limited to drugs. DFT is used in all sorts of fields, from material science to renewable energy. But here's the thing, traditional DFT calculations can get really complex and computationally expensive, especially when you're dealing with these really large, intricate systems.
Right, so that's where AI comes in to sort of save the day.
Precisely, AI, and specifically machine learning, is being used to turbocharge those DFT calculations. So instead of having to crunch through all those complex equations, every time AI algorithms can be trained on these massive data sets of DFT calculations and they learn the underlying patterns and relationships, almost like creating a shortcut to the answer.
So it's kind of like having a master chef who can just predict the exact combination of spices just by smelling the ingredients. No need to painstakingly measure everything out every single time.
That's a great analogy. And the best part is these AI-powered DFT models, they can achieve accuracy that's comparable to the traditional methods, but at a fraction of the computational cost, which is huge for researchers who need to run these simulations quickly and efficiently.
Wow, that's incredible. So AI is making DFT faster and cheaper without sacrificing accuracy. That's amazing. But what about those other AI tools you mentioned, like neural networks? How are those being used to actually simulate these quantum systems?
Yeah, so neural networks are kind of another powerful weapon in the AI arsenal.
Yeah.
Imagine this vast network of interconnected nodes, almost like a digital brain that can process information and learn from data. And we can essentially feed this brain data about a quantum system, like the positions of particles, their energy levels, how they interact with each other.
Okay, so I'm picturing this digital brain soaking up all this quantum information. What happens next?
So as the neural network processes this data, it starts to learn the fundamental rules that govern that quantum system. It's almost like teaching a child the rules of a game. And once the AI understands the rules, it can then start to predict how that system will evolve over time.
So we're essentially teaching AI to speak the language of quantum mechanics.
Exactly. And this allows us to simulate the behavior of these quantum systems without having to perform these incredibly complex calculations that are required by traditional methods. So it's really a revolutionary approach that's opening up these new possibilities for scientific discovery.
That is mind-blowing. Can you give me some concrete examples of how these neural networks are actually being used to simulate these quantum systems? What kind of real-world impact are we talking about here?
Absolutely. One really exciting area is in drug discovery. So imagine being able to simulate how a new drug molecule will interact with a target protein in the body. You could predict its effectiveness, you could predict potential side effects, and researchers are using neural networks to do just that. So it could potentially accelerate the development of new life-saving medications.
That's incredible. So AI is not just helping us to understand these quantum systems, it's actually helping us to leverage that understanding to solve real-world problems.
Exactly. Another area where these neural networks are really making a big difference is in material science. So imagine being able to design new materials with specific properties like strength, flexibility, conductivity. Neural networks are being used to simulate the behavior of materials at the atomic level. So it's really guiding the development of these next generation technologies in fields like electronics, energy manufacturing.
So AI is really becoming this powerful force in the world of quantum simulation, pushing the boundaries of what's possible and potentially even challenging the need for quantum computers in certain areas. But where does that leave quantum computers themselves? Are they destined to be overshadowed by AI?
Well, that is the big question, right? I mean, we've seen how AI is becoming this simulation powerhouse tackling problems that were once thought to be like the exclusive territory of quantum computers.
Hmm.
So yeah, are they going to end up being like the Betamax of the computing world?
Right. I mean, it's certainly tempting to think that way, especially the speed at which AI is advancing. But you mentioned earlier that quantum computers still have some advantages, especially when it comes to dealing with problems that are just fundamentally quantum in nature.
Exactly. And one area where they're really expected to excel is in simulating what are called strongly correlated systems.
Okay.
So remember how we talked about those weakly correlated systems, like a gas where the particles don't interact that much? Well, strongly correlated systems are kind of the opposite.
Yeah.
Think of it like a dense liquid or a complex solid where the interactions between particles are super strong and intricate.
So it's like trying to simulate the movements of a huge crowd of people during rush hour versus, just a few people strolling through a park.
Yeah, that's a great analogy.
Yeah.
And simulating those kinds of systems, those strongly correlated systems, it's incredibly challenging for classical computers, even with the help of AI. The computational complexity just explodes as the number of particles and interactions increases. But quantum computers, with their ability to actually exploit the strangeness of quantum mechanics, could potentially handle those simulations much more easily.
So quantum computers might be the key to unlocking new discoveries in things like superconductivity, where the interactions between electrons are super complex, or in designing new catalysts for chemical reactions, where,
Yeah.
the interplay between atoms is really important.
Absolutely. Those are areas where quantum computers could really make a huge impact. And then there's also the whole realm of quantum algorithms, like Shor's algorithm that we talked about earlier for factorization. These algorithms use quantum phenomena to perform calculations that classical computers just can't do no matter how powerful they become.
Okay, so it sounds like quantum computers still have some serious advantages up their sleeve, especially when it comes to tackling these really specific quantum problems.
Hmm.
But I'm curious, is it possible that AI and quantum computing could actually work together instead of competing with each other? Could they become allies in this pursuit of scientific discovery and, technological progress?
That's a really interesting idea. And actually, there's a lot of research going on right now that's exploring how AI can be used to actually design and optimize quantum computers. So imagine using AI algorithms to help overcome some of the technical challenges that quantum hardware is facing right now, like error correction and control.
So AI could help us to actually build better quantum
Yeah,
computers.
exactly. And it could work the other way around too. Quantum computers could help improve AI. There is a growing field of research that's focused on developing quantum algorithms that could speed up machine learning. So imagine training a neural network on a quantum computer. You could potentially end up with these even more powerful AI models capable of solving problems that are just impossible right now.
So instead of this battle for supremacy,
Mhm.
we might actually see this amazing partnership, this symbiotic relationship where AI and quantum computing are actually enhancing and accelerating each other's progress.
Right. Exactly. The future of computation, it might not be about one technology replacing the other, but more about figuring out how to integrate and leverage the unique strengths of each approach. It's a really exciting time to be watching all of this unfold, and who knows what incredible discoveries and innovations are just around the corner.
Well, I don't know about you, but I am definitely feeling like my mind is blown wide open right
Yeah.
now. We started with this question of could AI make quantum computers obsolete? And we've arrived at this much more nuanced and complex landscape where these technologies might actually be partners, not rivals, each one playing a crucial role in shaping the future of computation.
Absolutely. It's like this incredible journey of exploration and discovery, and we're really just at the very beginning of it. The important thing is to stay curious, keep asking questions, and embrace the possibilities, even the ones that seem like science fiction right now.
That's a great point to end on. So to all of our listeners out there, we challenge you to keep digging deeper. Explore the world of AI and quantum computing, and really try to imagine the future that these technologies might create. Who knows? Maybe one of you listening will be the one to make the next big breakthrough, to write the next chapter of this amazing story of human ingenuity. Thanks for joining us on this deep dive, and until next time, keep those minds curious.